Hi there, welcome to the second part of Learning Target 1. So this is, I guess last time was a little bit busy, so we're just going to work through one example today and just kind of uncover some of the terminology and the definitions that you need to know and that we'll move forward using in this unit. So Learning Target 1, a reminder is I know the difference between experimental, theoretical, and subjective probability, and I can calculate and interpret those probabilities in simple scenarios. So this is a warm-up question, like if you can just think about this for a second. In a game of cards, you win if you flip a card that is not a face card. What is your probability of winning? Very, very simple question if you understand probability. But we're just going to use this question to help us uncover some of the definitions and concepts that we're going to use, and that'll be helpful when we do more complicated probability. So a regular card a deck of cards has 52 cards, Joker not included unless there's otherwise noted. So Jokers would be 54. There's 13 cards of each suit, and they go ace to 10, which are the number cards. Ace is a 1, and Jack, Queen, and King. Ace is often used as a high card as well, but the face cards are Jack, Queen, and King of each suit. And the suits are clubs, spades, hearts, and diamonds. This is a good time here now just to make sure you're familiar with cards, because this is something we're going to be using. It's just something that comes up a lot to help us understand probability. So in the warm-up, what we call the sample space is all the possible cards that can be drawn. So it's everything from ace to king of clubs, ace to king of spades, ace to king of hearts, ace to king of diamonds. And so N of S is the number of cards in the sample space. N of S is just like a function that we saw last year in grade 11. It just means the number of an inputted sample space, which is S. So it returns 52 in this case. So the output is 52, and we're talking about cards. N of A is the number of cards that aren't face cards, because that's what happens. That's the way you win, is you win if you get something that's not a face card. And so if N of A is the number of cards that are not face cards, A is the number of cards that are not face cards, N of A, the number that there are, is 40. There's 40 cards in 10 cards in each suit that are not face cards. The event A prime or A complement is called the complement of A, and includes all the cards that are not face cards, so all face cards. So A prime is just everything outside of A, and in this case it's face cards. You can say it's A naught or A prime, but whenever you see this, it just means everything outside, and you can use that for structure in your own solutions. So N of A prime in this case is 12. Note that when you add up A and A prime, because everything in A and outside of A, you get N of S. And that's always going to be true because you're either in A or not in A. It's only one or the other. So it may be easier to find out how many cards were face cards. So there's 12, and then subtract them from 52. We call that the indirect method. The probability of A, which is what the question wants, calculated by dividing N of A by N of S. And so N of A is 40, divided by N of S is 52, and we call that 10 out of 13. You can do that as a decimal or a percentage, however you'd like. Venn diagrams are little pictures of ways to demonstrate the same concept, and they do help us wrestle through a more complicated probability as well. We'll spend more time in Venn diagrams later on, but I just wanted to introduce them now. So they really show A and A prime. Notice that A plus A prime is the entire N of S, so everything inside this box is N of S. A prime is everything not including the circle. Probability of A plus the probability of A prime. Think about that for a second. It'd be 100%, or 1.0, 1 out of 1. This is true. Probability of A plus probability of A prime is 1, so they add up to 100%. Very similar to, we saw the N of A plus N of A prime is N of S. It's the same idea. This relationship can be rearranged into two other useful forms. We can find out the probability of A prime from subtracting 100% and the probability of A, or the other way around. It's just kind of like algebra. We move one thing to the other side by subtracting P of A on both sides, or P of A prime on both sides. Back to the example, you've got A is 10 out of 13. That's the probability. It's 40 out of 52. A prime is the 12 out of 52, 3 out of 13. And you notice that when you add these together, we get 13 out of 13, or 52 out of 52, which is 100%. S is the box on the outside. It's all the cards. So you notice how your face card or not a face card. And N of S is 52. Okay? So there's some practice there. It's a very short lesson today. Practice. And this is a good question to kind of start thinking about, because that'll help to uncover the next couple days' work. If you drew cards from a deck and replace them after each draw, show that the probability of getting a face card is 23.08. How did they calculate that? How many times would you expect to get if you drew 13 times? So how many face cards would you get? 52 times, 1,300 times, 5,200 times. That's something you can think about. And then which experimental probability would be closest to 23.08? These are good questions to think about to start to uncover what we're going to do next. Okay?